In this lesson, we're going to be looking at the auto feedback simulation system. Now, above this video, you should have already seen a diagram that explains sort of the concept of this, that we have simulated feedback that goes into our software valve asset in this case, which we've been through on numerous lessons now that we're putting a simulated value in, and that is what our software is using in simulation mode. But what we're looking at now is if we're in simulation mode and this output request is on, so this is coming from our valve asset, and we have auto feedback enabled, which is a new variable that we have seen before in a previous lesson, but we've not explained it. If that is true, then to automatically set our simulated feedback to whatever value needs to be set. So if we go and have a look at the map quarter valve or quarter turn valve, we can see that on our open feedback branch, if we are in simulation mode and we have auto feedback enabled and our asset data, so that's the data that's being sent to our manager, is set to open request. Sorry, if open request is set to true, then do our sim open delay, which gives us 5 seconds flight time for the valve. So 5 seconds where it's receiving a open command, but it's not getting its open feedback yet, simulating the valve moving from closed to open. Set the open feedback to true after the 5 seconds is finished. And that's no different to if auto feedback wasn't enabled and we manually click the button to say open feedback. Now, the auto feedback blocks the simulation data that we would interact with off the buttons on our simulation HMI. I know we haven't seen the simulation HMI yet, but on the simulation HMI we would have a faceplate that has 3 buttons on it for a quarter turn valve, and it would be auto feedback enable and then open feedback and close feedback. When auto enable is set to false, we are coming down this rung here, or this route here, to turn on our open feedback. But when we are set to true, we are coming down this route here. So there's a reason why we block, and that's so we can't end up in a situation where somebody is using the buttons whilst we're in auto feedback mode and you end up with both feedbacks at the same time. You can do both feedbacks at the same time if you're testing that fault tolerance, but you can't be in auto feedback to do that, because auto feedback should always give you a healthy system that's doing what it's supposed to do. So that's why we block the simulation buttons. And how you want to manage that is obviously completely up to you, whether you disable the buttons on the HMI, whether you hide them, or whether you force them to a certain value and things like that. Like, we're talking about the concept here, not the actual do's and don'ts. But hopefully from this you can see how by setting the by looking at the open request coming from our software for the manager of the valve, when we're in simulation mode and auto feedback, we then set the actual feedback in the data back to whatever it's supposed to be. So in this case, open feedback, because we're asking it to open. If we come down and have a look at the closed, we've got the same thing for closed, simulation mode, auto feedback. If it's getting a closed request, then we give it the closed feedback. In this particular case, for this quarter turn valve, there might need to be additional things added into this that comes from the asset data. So we may need to understand what mode we're in, because right now we're saying if you're being asked to open, then feedback that you're open. However, we have a spring return close on this valve if you're in mode 1. And by having a spring return, we don't pass a close request to shut that valve. So we would pass a simulation auto feedback open request, open this valve saying open feedback. But then what we would do is remove the open request to say open feedback, but there's nothing to say, okay, now you've got your close request, your close feedback, because this system, as of this moment, doesn't know anything about the spring return. So we might have to add in here a new network, a new rung or branch, and say in here, if you are in this particular mode, where we are spring return close, then if you are no longer receiving your open request, then send the close feedback. So we'd probably actually be doing it in this network here, which then passes the close feedback. And I haven't got around to testing this stuff yet because the simulation HMI is not built. But as we go through that stuff, obviously this will be updated to pass those test requirements. But the concept is what I'm explaining now, that in this layer here, in this block here, this FP2 map quarter turn valve, we are able to build the auto feedback model that says when you're not receiving this, you should be doing this. When you are receiving this, you should be responding with this when we have auto feedback turned on. When we don't have auto feedback turned on, we are in complete control of what happens using this simulation data, open feedback, and closed feedback here. So with that being said, let's just have a quick look at the map modulating valve, because this is an analog example, which are much more straightforward. So we have, if you're in simulation mode and you're not in auto feedback, then simulation data raw, which is our raw value in the simulation data, that gets moved into the feedback. However, if we are in auto feedback, then we have whatever our output is in our data set, the position required, that gets moved into our feedback. And it's at this point here between the auto feedback and this move command that we may decide that we're going to put in a ramp system, or we're going to put in a timer for stepping, and whatever it is that we're controlling, we have control here to add in how that response should be. Obviously for this valve, this modulating valve, it's just a straight, right now it's just a straight, if I tell you to go from 0% to 100%, it will do it instantly. If you wanted to see a ramp time or a flight time for that valve, then we would have to put either a ramp in or incremental changes on a timer or whatever it is that we need to do in order to get the desired output, and that would need to sit here, which is what we've done for the quarter turn valve with our timer here, which just limits the time between sending a open command and seeing the limit come back. So that's the concept of an auto feedback system. Hopefully the key sort of takeaways for it, and hopefully you can see this, is that it has nothing to do with our management layer. If you didn't include auto feedback, it wouldn't break the manager that manages your asset. It also doesn't really have anything to do with standard mapping of the system, because if we were to remove these three things here, which are all to do with auto feedback, then you'd end up with, if you're in simulation mode and we're simulating auto feedback, you'd have your open delay and then you'd get your feedback. So by not including auto feedback in your system, if you don't feel like you need it, you're not any worse off. You just don't have the facility to be able to sit back and know that your assets are going to respond the way you need them to whilst you're testing sequences and things like that. So definitely worthwhile having when you're running through sequences that might have 20 assets involved or more. Testing those assets in isolation using the normal feedback, no auto feedback system, using the buttons to check basic functionality for alarms, discrepancy, failures, things like that, and being confident that that asset works the way it's supposed to work. Then you stick it into auto feedback and know that it's not going to affect your sequence, because your sequence will always have the correct feedback from that asset. That's really where the benefit of auto feedback comes in. But I just wanted to stress that it's not an integral part of the system. Hence why in the diagram above this video, it's dotted lines there, because it's sort of an add-on to the system. If you can't really visualize how this is coming together, or if you're struggling with the sort of concept, then later on in the course, when the simulation HMI is developed and you get to that lesson, you will see with a much more visual representation how this system interacts with the main code and how it all comes together.